We are back. Got some audio issues. Well, good
That was
evening,
too
Jan.
long ago.
Yes,
That
I
was
know.
too long ago. Finally
Indeed.
back.
Yes, indeed. Yes, yeah. How have things been?
Well, everything ended well.
Mm.
So I tried to catch up a little bit of work.
Mm-hmm.
But on the DWS side, I watched this morning your session on Cursor,
Uh-huh. Yep.
and I forgot even more about it. I saw that you ended up mixing the models with the user interface,
Mm-hmm.
and I said, "Oh, that's where we were."
Yeah. Yeah, that's true. Yeah. Yeah. So using the DWS project as an example, it's like, oh, well, we have to pick up from right here. Um, yeah. So yeah, we can spend a bit more time with Cursor, and see what some of the best practices are, and how to get things going. Or if you've
Yes,
got some other questions you would like to cover, we can do that.
I think Cursor is fine. Now I saw something. I think it was on YouTube about Cursor.
Mm-hmm.
That apparently the extensions in Cursor they are not. They come from their own collection,
Yes, yeah.
and
There's
and
a history there, and yeah, we're still trying to work things out. But um,
apparently there was a guy who who got a virus or some
mm-hmm.
who got his computer hacked. So for the moment, is it best to keep it on a virtual machine, or should it be reliable?
Yeah. I run it on my host machine, so I believe that there's that the Cursor platform is fine. The plugin architecture, which is the same architecture as Visual Studio Code, that introduces another vector, and then um, the fact now that Cursor has to use a different marketplace than the one that Microsoft maintains, that that basically puts the puts the onus on Cursor as an entity running a marketplace to make sure that they secure their plugins, which is something that Microsoft is doing. However, they're not allowing the forks of Visual Studio Code to participate in that marketplace. Yeah, and then there's another area that you need to be careful of with regard to security. You might not have played around with this yet, but MCP servers. They are another way of introducing new code into your ecosystem, and so therefore can be used safely, but have to be used carefully as well. MCP servers are really cool because they are ways that the LLM can get access to tools and services that are hosted elsewhere. For example, you can have an MCP server that connects to your Jira system, and now you can have the LLM pull a ticket and say, okay, we're going to work on this user story. It can read the user story. It can change the status. Okay, let me mark this as in progress. And then when it creates a pull request, it can attach it to the user story. So it's basically got that tool available to it. I use an MCP server that connects to a database. So Postgres database. I need to write a query. I could write it up in SQL, or I can talk to the LLM. The LLM has access to the SQL connection, and it can write a query.
So you can just describe the data that you need,
mm-hmm.
and then the LLM will form the query automatically and access the data.
Yes, to a certain level of success. Get too complex, and it just fails. But once you know where that line is, it's just pretty useful.
Yeah, because I found it amazing, but that's also complicated. If you see all the changes that Cursor made in the
Hmm.
code, you still have to verify everything. You need
Yes,
to know the code very well and to have a good overview,
absolutely. Yeah, that's an important part of the
because
process.
otherwise you're completely lost.
Yep.
Um, so I think the main thing is to keep the changes really small bits and to try to keep it locally.
Yes. Yep. Exactly right. Yep.
And to be very, as you said, be very specific, because otherwise, if you're not careful in what you ask, uh, the assistant will work and continue and do a lot of things that you never asked for.
Hmm. Yes. Yeah. So yeah, there are ways that you can put it into a mode where it continues working. I might have demonstrated in the video my test driver development cadence. Actually, I probably didn't in that video.
Mm.
But yeah, you can give it different roles and then have it move from one role to the other. Oh, okay, that's why I didn't demonstrate it. That's not a feature available in Cursor as of yet. That's available in RuCode and in Claude Code. And RuCode is my powerhouse. I return back to RuCode when I've got a really tough problem I need to solve. But it's the most expensive option for me. Claude Code is second. But yeah, with those you can define multiple roles, and then you can have it switch from one role to the other, which is a perfect fit for TDD.
Okay.
So yeah, in Cursor, there's Cursor rules, which are kind of one step in that direction. And I think I did talk about Cursor rules a little bit.
Yeah.
Yeah, that's a pretty powerful way of using the tool. But with Cursor
So,
rules, yeah, you figure out for this task what extra information do we need in context, and then you load that in, and it uses it.
because even the rules that it generated is not only useful for the tool,
Hmm.
but it would even be useful for myself, just to, after a while you've not been working on it, you forgot everything, you just let it generate the rules,
Yep.
and it gets you back onto track very fast.
Hmm. Yep. Give me an architectural overview. Whoop. There's a
And so
markdown
the
file. Yeah.
reason why you say use Cursor, because it's useful for most of the programming and it's the cheapest option.
Yes.
While RuCode is what is the price of RuCode?
Yeah. So RuCode uses your Claude or your Anthropic AI key. So so basically, RuCode itself is just a free and open source plugin to Visual Studio Code, but all of the calls that it's making are going to Anthropic, and then you're getting charged for those tokens. And so when I'm using RuCode heavily, I'll use it at least $100 a month. So it's not cheap, and the way that that RuCode, the way that I've especially the way that I've got it configured, it's sending more tokens, and it's doing things in smaller pieces. So therefore, there's a lot more traffic going back and forth, which means
Well, Cursor is about $20 a month, if I'm
yes.
not wrong. Yeah.
Yep. Yep, and with the $20 a month, you get a certain number of premium calls with that, and then they kind of keep track of your usage. Once your usage reaches $20, then they have the option of charging you additional money for that. But in my experience last month using Cursor, I was using it pretty heavily last month. I deliberately shifted my focus. Let's just try to do things with Cursor, and I used about $35 worth of their tokens, but they still only charged me the $20.
Okay.
Yeah. So so basically, I'm taking advantage of deals that they have with the with the models, and it helped that that GPT-5 came out just recently, and OpenAI is giving away GPT-5 access for a limited time to all of these all of these third parties. So so yeah, I saw it switched from Claude to GPT-5 when I looked at the log, and yeah, I used a lot of GPT-5 during that time.
Okay.
And so yeah, they're taking advantage of OpenAI money.
No, but it's amazing. Also, the conversation with the tool, it's like you say, don't consider it a human, because it almost becomes a human.
Yeah. Yeah, I think that considering it a human leads you to to practices that are probably not optimal, and then in addition, it might actually affect the way that you treat other people, and I definitely don't want to do that. It's like, yeah, I'm working with an actual junior developer, and then when they do a thing a certain way, it's like, I would reprompt the LLM in this way, so getting into Teams and typing, it's like, wait a minute, no, that's a human being. And it's mostly that with the human being, I want to grow them. I want them to become a senior developer. With an LLM, I'm not going to grow it. It's just not going to happen. So, so yeah, I'm not even going to try that. But with the humans, like, oh, you made a mistake here. Let's not correct the mistake. Let's say, hey, go research this and see what you find. Oh yeah, there's that feature in Entity Framework. Let's use that feature. Okay, cool. Yeah.
Yeah, but if you see, even with Cursor, you go to have a retrospective on what went wrong and adapt the rules and the guidance.
That is true. That is true.
Yeah.
Yeah, and that's you could see that as like a miniature version of helping it learn and grow, but that's very limited. Yeah, that's more akin to when you're working in a team and you update your coding practices. So not even your working agreements, not the way that you're going to communicate with each other. I mean that's already too far above what I'll do with an LLM. But I'll definitely do that with humans. But just how do we code on this project? It's like, okay, for this project we've chosen to use clean architecture, and so therefore we are going to have these dependencies, but not those dependencies. We have to abstract here, and those are the the things that we need to capture in those rules so that it can generate the right code.
Okay, so keep a clear separation between Cursor and humans.
Yes.
and the moment that I call my wife Cursor, then I have to say, confused two names.
Yeah, that's a problem. In fact, I think I would like to start with this. It's going to take me a little bit to get this all set up, but I did. The reason that we didn't have a live last week is because I was teaching a class, and this thing is stealing the pictures. There we go. So so this was a class on AI and ML for application developers, and as part of this class, I put together a real quick demo, and I would like to share that demo. So let me start our stand-up. So we're going to get the bing bing. So there's our... Okay, there's Zoom, and then I will do the share of that screen. Okay, so we've got the screen share. All right. Gotta push that button. Now you should see the screen share.
Yeah, now I see it. Yeah.
All right, excellent. So So yeah, we've got all of these labs in AI and ML4 developers. Some of them are about machine learning, as in building a model, based on some tuples of numbers predict what's going to happen. But some of them are based on generative AI. So we go through a RAG example, we go through a spam detection example. So, but to kick things off for the generative AI, I built this little thing called the token visualizer. So let me get the token visualizer started up. So from here, I'm going to see, did I leave good instructions? We go to the token visualizer, and then I should have everything installed, but let me just go ahead and do the, oh, I need my OpenAI API key. That's right. So I will go ahead and grab an OpenAI API key. So let me go ahead and show this part of the process too, because I'll be destroying this API key after we're done with it today. But we want to go to OpenAI.com, and I get logged in. I want to log into the API platform. So now I'm logged in there, and I've got different projects so that I can kind of keep things separated. The AIML for the application developers project, in there I've got some API keys. So I want to go to, where did it go? I didn't put it that far down. Let's see. Oh yeah, that's right, I'm in Docs. I want to switch to Dashboard. Now I can go to API keys. Okay, let's create a new key. We'll create it as a service account so that it's it can't get access to the stuff that I do, outside of the service account. So this is going to be the historical modeling demo. So in that project, create a key. We'll copy that key. And then we're going to come in here, and I want to edit this .env file right here. So I've already, it's in backend.env, so I've already copied from the example. And this was the old key that we used during the class. So I will just pop that new key in there. And now it should be all set up to call OpenAI. So that's going to give me access to the GPT models. And now we can just
Why was that
run
old
them.
key not valid anymore?
Because I shared that with the class for the
Okay, so
demos, and then I destroyed the key. Yeah. Okay, so then there's this little script in here called run.sh. So that will start up the front end and the back end. So where's the back end? And why is this running in Git Bash? I must be in, well, let's see if this actually works. I don't know if this is going to work in Git Bash. Otherwise, I'll switch to WSL. But let's go to this front end page that should be running here. Yeah, I don't think that's quite working. Let me switch to WSL. So where did my terminal go? Oh, my terminal just went away. Okay. All right, let's go Ubuntu. So we are here. I want to go to projects and ML let's see, this is under improving. And this is... oh my goodness. Did I actually run this under Windows? What did I do? Let's see. Where are my projects? We have...
in there?
Yeah, let me just... So, projects improving, yeah. Oh, okay, yeah, well, this is actually loading it from PowerShell. Yeah, but, oh, okay. Yeah, I did the class, from Windows, but this run.sh, yeah, I did that from my my Mac. So, yeah, this is just me getting confused with what I was doing. So let's go to PowerShell. Okay, go to projects, improving, and then okay, so I want to go to the token visualizer. Okay, and now from here I want another window that is in the same place, so go there as well. And now this one will be the front end, and this one will be the back end. And now I should be able to do an npm run dev, get the back end started up. And then that's listening on port 3001. And then the front end, npm run dev on the front end. Okay, now we've got a link here that should work. Okay. Yeah, and there we've got the token visualizer, the token probability visualizer. Okay, so what we've just done here is we have sent a prompt to GPT-3.5 Turbo, a small, fast, cheap model. Pretty old at this point, not terribly capable, but still works the same way as GPT-5 does. And then we got back a response. So if I hover over each of the different words, I'll say for right now, in the response, I'll see a different probability for what could have happened. So here, rather than hello, it might have said hi. And then here, rather than an exclamation point, it might have done a period, or might have just a comma, or continue the sentence.
Mm-hmm.
So you can see kind of the probability of different continuations. So this setting here, the temperature, which actually I'm not certain if this is truly working, it might be working. Yeah. Okay, so by increasing the temperature, I increased the likelihood that it's going to go a little bit further down the list. So even though high only had a 10% chance, because I bumped the temperature up, or because I got lucky and we just rolled a D10 and got a 1 on it, but it went down to the 10% rather than up at the 90%. So it decided to continue with high. And now, given the input hello, hi, it predicts there, and it goes ahead and takes that 80%, even though it's got a nice high temperature. If we bump the temperature up even further, then, yeah, this is why I'm not entirely sure that the temperature setting is really working. I just kind of vibe coded this example. The complete opposite of what we were talking about before, where you don't care about the code. I don't even know what this code looks like.
Because now the high is at 6% only.
Oh, that's true, yeah. I hadn't actually noticed that before, but yeah, you're right. So even the percentages that you're getting back are probabilistic. So I just made the assumption, without testing with the tool, that you were always getting back the same probabilities. But apparently that is not the case. So let's set the temperature down to a reasonable level again, just in case it is working. And so this is kind of demonstrating what these tools truly do. It sounds like, it seems like to us that they understand our intent, that they follow instructions, that they reason. We even call some of these reasoning models, but none of that is actually happening. They are predicting the next word. I recently heard Scott Hanselman refer to this as Family Feud. So it's like the response to hello, top 5 answers on the board. I say hi, only 6.8%. That's really all that these things are doing. And now with this tool, we can run some interesting experiments. So let's suppose that I were to give this a coding task. So we want it to write.
Michael,
Mm-hmm.
Michael, but so this hello, how can I assist you?
Mm-hmm.
That is a prediction of what would follow at the prompt that you wrote. You wrote hello as a prompt?
Yes. Yeah, that is nothing more than a prediction. Yes.
Yeah, but so if you would press on the submit button now, then he would predict the sequence of write pseudocode 4.
Yes.
Okay.
So yeah, it predicts a program that checks if a given number is prime. So in fact, that wasn't what I was about to type, but that's a pretty good one.
Yeah.
So yeah, there's a few things that you can kind of see in the pop-up here that's kind of interesting. You can see a finding. So it's not like it has a dictionary. Here are all the words, and it's just going to give one rank to each word. The model is much more messy than that. So we're actually getting duplicates out of this. We should also see parts of words. So far, these are complete words, which is kind of throwing a wrench in. Okay, there's one, EU, or QAL, QUAL. So it's not strictly words that it's predicting; it's tokens. So tokens include words, they include parts of words, they include single letters, numbers, punctuation. It's all part of tokens. I guess that one's a space. Yeah, it predicted a space, which is kind of. Yeah, I guess. Yeah.
So
I guess it wanted to put spaces before the.
Statistically based on the content that it knows, for example, internet.
Yes, precisely. Yep. So just based on its trading data, what is more likely to occur next? Which there's an older mechanism that you might have heard of that does that next word prediction. It is called Markov chains. So Markov chains are based on information theory. Claude Shannon didn't explicitly write about them, but he got really close in his work. And then, so a Markov chain, you could say, just give me the occurrence of every word in the English language. just a probability occurrence of each word. And now if I want to, predict a word, I could just look it up in that table. But that means each word is independent, and you get gibberish. But with a Markov chain, you now you build a small state machine. So given the word right, what's the probability, what's the likelihood of the word that follows? And so it might be, write a poem, write a song. And pseudocode is probably pretty far down that list. But now that you feed write and pseudocode into that state machine, now it's got a different table for what comes next. And so you build a small-ish state machine, because if you try to get too big, these things get out of hand. And then you kind of sum over all of the states, so that you get a you can, well, if you do just sum over all the states, you can you should converge to just the general independent probability. But by using the state machine as it is, you can start to produce text that, at least in structure and in syntax, looks like reasonable structure. And so with the Markov chain, you could get it to write poetry, and it kind of looks like poetry, but it wouldn't rhyme because it can't see that far back, and it wouldn't really make sense. But so this is doing something more powerful than a Markov chain, for sure. But you can explore with this tool kind of the limits of what it can do. So let's go ahead and let's copy that part. Yeah, I did. I should vibe code it to say, hey, let me do a copy and include spaces. But so now we are going to continue. So basically that should be this continuation right here. So if things go the same way that we did, it would predict from this point forward. It looks like it's more likely to predict OR, but let's see what happens. And so we do that, and now it predicts some ticks. Okay, so that tells me with the tick token followed by the tick token that it is actually trying to write out some embedded code. That's what it has seen in its training data, is tick 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 to write out some code. So function is prime number colon. That looks like Python to me. That right there is probably not a space then. That's probably a carriage return. So if number is less than 2, return false. So it looks like it was able to complete that programming task. This is probably a good example of a prime checker. It's doing a well, actually I'm not seeing an inner loop where it can check for factors. So might not be a good example. It is calling itself recursively. Yeah, interesting.
Yeah, it's recursive, so. And you have, if less than 2, then return false, so it jumps out.
Mm-hmm. Yeah, so if number is divisible by I, well, that's not an actual Python, that's not Python code. Or actually, maybe it is. I, so where's I? Oh, okay, there's the loop, for I from 2 to square root of number. Yeah. Oh, I did say pseudocode. I said pseudocode, not Python. So yeah, that's good. So yeah, it looks like it's following instructions. It looks like it's actually writing out pseudocode for me. But in truth, it's predicting, and I think we can find a problem that demonstrates that. So I'm going to go to ChatGPT, and in my chat history, I've got a there it is. Yeah, I've got a scenario that I asked ChatGPT to create. So create a confusing scenario related to blocks on a table and a person manipulating those blocks. Include multiple steps. And so it came up with this. And so let's paste that in here and see what it's trying to do. So you walk into a room and see 3 blocks, red, blue, and green, stacked neatly on a square table. Alex is standing beside the table. First, Alex takes the green block from the top and places it on the floor to the left side of the table. Then, without looking, Alex grabs the blue block and sets it on top of the red one. Next, Alex picks up the green block from the floor and puts it on top of the stack again. But then Alex flips the entire stack upside down and slides it to the far edge of the table. Finally, Alex removes the middle block from the upside down stack and places it where the green block was on the floor. Except now that spot is taken by the blue block, which Alex swaps into the stack in the same place as that the middle block came from. So first of all, ChatGPT, which is really just running GPT-5, came up with a scenario that doesn't make any sense. Except why would the blue block be on the floor? If we were to follow these steps, we would see that at first green is on the floor, blue is on top of red, and then now green is on top of blue. So flipping it upside down, blue is still the middle one. So Alex removes the middle block and places it where the green block was. So up until this point, this should be the blue block. And now here it says, except that's where the blue block is. So with this completely impossible scenario, let's see if we can solve a problem. So when Alex steps away, the stack on the table, the floor is exactly 1 block on it, and you're trying to work out which block is where. We will simplify this task. Which block is on the floor? So it says the blue block is on the floor, which would actually be correct if we ignored this impossibility right here. So did it get it right? Let's see. Hover over blue, 58% green, 22% blue, 19% red. It didn't reason through it at all. It continued in the style of that composition, and it said, well, it could be one of these 3. Let's give probabilities to them and then roll the dice, see which one comes up. And blue happened to come up. Now, granted, this is an older model. So I didn't actually play around with the model selection. I don't know if this is truly working, but let's try 4.0 Mini. It did take a little bit longer. So now it is using a newer model. So now it's continuing with what looks like reasoning. So determine which blocks are on the floor. Let's break down the action step by step. Initial stack. Green, blue, red. Good, got to that point. It said that was the initial stack, green, blue, red. That's not... Yeah, that was not actually in the problem. After these motions, then we end up with actually red, blue, green. I think. No. We end up with blue on the top. Takes the green block from the top, places it on the floor. Okay, yeah, it was the green. Second action, grabs the blue block and sets it on top of the red one. Okay, so I told it max tokens 28. Let's let it continue a little bit. Go for it. what it's actually doing behind the scenes, it's feeding one token back at a time, so we usually see it typing on the screen, but I didn't implement the server sent events on this one. So because of the stochastic nature, it it took a different path. But yeah, it's still saying green, blue, red there. It swaps the blue block to the stack of the same place where the middle block, which now it thinks is red, came from, so after the swap. Therefore, the block on the floor is green. So it got to green this time, and I want it to show me the probabilities. So green is 90%, the is 80%, so that 8% might be followed by a different color, but it seems pretty sure about green this time. Let's give it one more shot and see if it comes up with a different reasoning and perhaps a different answer. So now the stack is blue, red, green. Alex removes the middle block, which is red, so it is consistently coming back to red there. And so now the block on the floor is the red block with a 99.8% probability. So yeah, this kind of reveals the stochastic nature of these models. And even though we call this a reasoning model because it does this kind of stuff, still it's not true reasoning. It's prediction of something that resembles reasoning. So we can play around with this a little bit more. So let's take out this confusing part here. So Alex removes the middle block from the upside down stack, places it where the green block was on the floor. And that's it, because now there's no block on the floor. So now which block is on the floor? If we take out that impossible part of the scenario, then it says the red block. And if we do it again, does it get red again? And it now gets the blue block with a 98.9 plus the 1.1, so 100%. It's just going to be, is it lowercase blue, capital blue, or uppercase blue? Yeah. Now that is 4.0 mini. Let's actually give this to the big one. Well, not the latest big one, but blue block. Or try again. And okay. Now with the big model, at least twice it predicted blue. 3 times blue, which, if I remember correctly, blue is the correct answer. So what does this mean? Does this mean that as the models progress, it gets better at reasoning? Or does it mean that it's now past the point where this problem is just on the edge, and it says, okay, now this problem is within the space of what it could reason about? Yeah. I'm still trying to figure that out myself. What I can't square in my head is I see exactly what it's doing. It's showing me probabilities. And so it's rolling dice at every token. And I know what it takes to solve a problem like this. And that's reasoning. That's imagining the scenario, stepping through it. Is a stochastic model enough to solve those kind of problems. It doesn't seem to me like it is, and yet once we get to a certain threshold, we start to see it solve those kinds of problems, or at least it appears to. So that's the other thing that I'm thinking. As we're building bigger and bigger models, are we training them to fool us? So the models that produce the most reasonable result are the ones that we reward, and then therefore they become the next models that we use. And the reasonable results are really just based on our perception of them. That's why we got thumbs up, thumbs down on ChatGPT. So are we training models specifically to pass the Turing test? And that's what we're starting to see, is something that is fooling us, even the researchers. Definitely makes me think.
But it's already amazing, the way it handles and the way it seems to understand text. It's just an illusion, but it's a good one.
Yeah, I like that phrase. Yeah. Yeah, I don't. I don't know. It's certainly a useful one. So for language tasks, it's quite useful, quite powerful. So one of the things that this kind of shows me, the fact that it's taking this sequence of tokens now, once it tries to predict on, it has this original prompt plus the word follows and all of this. So it's got all of that, and then it runs it back through. So that means that on is predicted based on all of this, and so therefore it's going to try to pick something that is consistent with all of this.
All that came before.
Yeah.
So it's like the Markov chains.
Yeah. Yeah. There's. Let's try this experiment. I want to see if this changes things. So first, I'll switch back to the small fast model. And in fact, we don't need a whole lot of tokens for this one, so we'll just pop that down to 256. So answer only with the word blue, green, or red. So now we're giving it a constraint. I'm going to give it one more constraint. So let's first run it with this constraint. So at least for GPT-3.5 Turbo, it should answer with just that one word. So again, we've got a random assortment of what it could be. Although red made it way further down the list this time. Interesting. Yeah, I wonder if there's some context that it's actually sending back. Even though I didn't tell it to do that when generating this program, it might have kept that context, and so maybe it's got that reasoning. Let me stop and start the back end just to make sure that let's first of all see if it's coming through the front end. So here's our network tab, submit, generate. So generate is just the payload, so just the prompt and the model. Okay. Nice and simple. Well, now here it predicted green, but still that's just based on those random probabilities. So yeah, now I want to stop and start the back end. So stop that, start it again, because if there is state that's maintained from one submission to the next, then the back end would be
should be
storing
reset.
it. Yeah. So now we submit and we get blue, and yeah, we are back to pretty even probabilities. Okay, so yeah, I think it was actually coded up to keep history. So yeah, GPT-3.5 was cheating off of GPT-4o's paper. So now if I continue this constraint and say follow your prediction with your reasoning, this should reveal something else pretty interesting about this behavior. So first of all, it makes the prediction. The prediction of blue is now a bit higher than it was before. And then the reasoning, the blue block was placed on top of the red block, so it is in the middle of the upside down stack. Which, once we reason through this, okay, here it's happening right in front of me. This surprised me because that is a really concise description of the full proper reasoning. And the only thing that it had now is the GPT-5 Turbo. It didn't have access to the 4.0 context anymore since we reset it. I asked for max tokens 256. So because of that, it tried to squeeze the response into that size. If I bump it up to 512, we get a larger response. It's still not fully 512, but it is stopping at the end of a sentence. So it's not just a hard cutoff. The model knows how much longer it's supposed to produce. It didn't follow the constraints this time, because it was answer only with the word blue, green, or red. So it violated that constraint, but it still gave the prediction before the reasoning. And now here the prediction was green. Okay, so I think this run actually shows the behavior that I'm talking about. So by the time it got to predicting this token, it was saying 60% green, 40% blue. Then it rolled the dice. It picked green, which was the most popular one, but there was certainly not a guarantee that it was going to be green. And then, now that it has that prediction, it comes up with a reasoning for it. So the reasoning had to follow the prediction, based on how we know these things work. And so now if we read through the prediction, the reasoning explains why green is the right answer, even though we know, based on now the fact that we've made this a possible scenario, that blue is the correct answer. So Alex first took the green block and placed it on the floor. Then Alex picked up the green block from the floor and put it on top of the stack again. Actually, it said right here, the green block, and puts it removes the middle block. So that part is correct. So the green block ended up back on the floor. It skips from here to the green block back on the floor. Up to here, it's correct, but Alex pulled the block out of the center of the stack, which was the blue one. So because it needed to be consistent with its prediction green, which was only a probabilistic prediction, it made up a rationalization. And so I think this is a pretty powerful demo of what these things are doing and what the limitations are. And I wonder if humans do the same thing. We come to a conclusion, and then we rationalize our conclusion, and now the drive to be consistent forces us to stick with that conclusion and not rethink it while we're rationalizing. Say, hey, wait a minute. Yeah, it was on the top, but the blue block was in the middle, so it's the blue one that's on the floor. Oh, never mind. I predict blue.
I think in purchasing behavior, it's definitely true.
Mm-hmm.
People want a new car. They go and see the car, and then they start finding reasons to buy it.
Yeah. Yeah, I think you're right.
In fact, of saying, okay, what are the reasons? Also, if it costs so much to repair the old one, the maintenance, and it's so old, so we better buy a new one.
Mm-hmm.
Uh, so, but if in logic, I don't know.
Yeah. So now I'm curious. Um, and yeah, I don't think that that humans switch modes and say, okay, now I'm being logical and reasonable. As much as we like to tell ourselves that, especially mathematicians and scientists.
Mm.
Yeah, it's like, okay, I am in math mode, I am in science mode, I'm just going to follow this. I still think we get hung up and we get caught out on those things. It's just that the process of mathematics and the process of science has built-in checks, because you need to collaborate with others. Just writing a proof, on your own is like, hey, I have proven that P equals NP. I have, proven the twin primes conjecture. I've found a way to square the circle, and you write that proof, and it's like, yes, I've convinced myself. But yeah, you show that to somebody else, and they can find the flaw. So yeah, okay. So I've reset. What I want to see is just go all the way to GPT 4.0. We saw that 4.0, was it was conditioned to give its reasoning first. Here I've given it the constraint to follow the prediction with your reasoning. So let's see if it follows my constraint or if it follows my constraint. Blue. With a very high probability. Green still has a 3.2, red has a 2.0, but blue has the majority.
80, almost 90.
Mm-hmm. Yeah. So then it goes through the reasoning, which at first glance is correct. Yeah. So it even shows this is what's on the table, green and red. Yeah, because it put green on top, took the blue out. That's right. Yeah. So yeah, it's doing the right thing and outputting its prediction. So this, what I said before is a bit of a, that was not quite accurate. Here's why. So okay, so what I'd said before was by the time it made this prediction, it was stochastic, and it chose that from, and now it had to stick with it. So that part is true because it predicted different probabilities. However, here, I think this is showing something a little bit deeper. That means that taking what I had just said to its conclusion is not correct. So it's it did predict this time a really high probability for the correct answer. How did it make that high probability prediction before it output the reasoning? And I did see a paper that that kind of explained this behavior. So the researchers, basically the way that these models work, you put a sequence of tokens into the front of a neural network, run it through a lot of hidden layers, and then there's a condition called attention, or a process called attention, where you've got you're basically predicting relationships between and among the tokens, and then you're doing that over and over and over again. You can think of that as finding the structure, finding the syntax of the tokens, or if something is referring back to something that was previous, you're finding kind of that back pointer or that relationship. That's kind of the intuition of it. It's really just math and and high numbers and low numbers, but you go through that process, and then when you get to the end, what you have is a matrix, one of those vectors is the next token prediction. But there's a lot of extra information in that matrix that you don't use in order to present the next token prediction. So that information is thrown away before you do the next iteration. So this paper kind of peered into what was in that information that gets thrown away between tokens, and they were able to find that it kind of has a direction of where it might go. So the model actually did have a chance to, air quotes, reason through the rest of this problem before it made the prediction of blue or green, or red in this case as well. And so that, I believe, is why we're seeing a much higher probability on blue. Nevertheless, had it rolled a low number and chosen green or red, it would have continued with a rationalization rather than reasoning. So, yeah, the way these things work is fascinating. And so, yeah, all that to say that we want to be careful about how we use the tool, what it's good for, and what we should avoid using it for. So it's really good for language tasks. It's good for consistency, but yeah, it is not truly reasoning. Wait a minute.
But progress is going very fast, so who knows, in 2 or 3 years' time.
Yeah, and that's kind of the language that you hear from the AI researchers. They're talking about AGI. AGI is 5 years out. I am very skeptical of that claim. So, based on what I've seen from what these things do, it doesn't appear to me that AGI, or that even less than AGI, something that is truly reasoning, it doesn't look like that is down this path. I see it conquering harder and harder problems, and in fact, I see the benchmarks about it's being trained on the SWE benchmark, measuring it on coding tasks, or there's a benchmark for mathematical proofs, and I see it doing better and better on those benchmarks. I get that, and I think that they are trying really hard not to have the benchmark pollute the next generation. So I'm not not calling out that there might be some cheating going on or anything like that. But I think that the benchmark is really measuring how complex of a problem is it able to work through given just the attention matrix, just that mechanism. But I don't believe that. I believe that there's a limit to that. I don't believe that there is a solution down that path, just using the attention matrix, that gives us anything approaching artificial general intelligence, let alone general reasoning. So I think two things are happening. One, these things are trained to fool us, and the people who are experiencing them more than others are the researchers. And so I think that we've already seen some researchers being fooled and thinking, oh, this thing is alive. I'm going to go tell everybody, hey, this is a living being. And in hindsight, we look back at that with how the research has progressed, and we say, no, clearly that was incorrect. And I think even further hindsight, we can look back and say, no, your prediction of AGI clearly incorrect. But I think there are incentives for them to say AGI is 5 years out, because that brings in the investment. So I think that is at play as well.
Yeah, definitely, because
Mm-hmm.
that's what pays them.
Yep.
Um,
So yeah, I really enjoyed playing around with these things, finding what the edges are. I enjoy using them in my own coding exercises, because it does produce very consistent specifications, much more consistent than I can. It's like, oh, this is wrong, let me edit that. Well, I didn't fix all the other things that I had to edit in order to keep it consistent. Versus tell it, hey, this part's wrong, and then to see it make edits here, 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 and here. Say, oh, okay, keep it consistent. And yeah, code generation. I think what I've learned from this is that a lot of code is not information dense at all. That just thinking about information theory, how much information do you have to apply in order to get this specific message? Replace message with program. If you can give a machine a specification and it comes out with a program that implements that specification, then all the information that it needed was either in the specification or made up along the way. And we see these things make things up along the way. That's not hallucination. That's just what we call it. That's a feature. That is how these things work. So I think that for people to write a consistent and correct program, they actually use very little information, and then they have to fill out the rest of it. So a lot of it is boilerplate or patterns or conventions, and we could find more concise languages that capture just the information that is necessary to generate the program. I think that's really what the success of models on software development tasks is really telling us. Our languages are just too verbose.
yeah,
But
with the right definitions. Yeah. Look at the word specification.
Mm-hmm.
You say specification in normal language or specification in Jinaga context.
That's true, yes. Yeah,
Yeah,
I was
so-
just talking about specification in normal language. Yeah, one word means two different things. And actually, I think that the fact that there is a specification in Jinaga that does so much, and if you were to write the same code in more traditional architecture, you would have to do all those things yourself. I think that's a demonstration of the fact that we can get to a much more concise language. So I don't think a Jinaga specification is the most concise, but it's certainly a lot more concise than what we'll typically write as call an endpoint to talk to the backend, and now it runs a query. Okay, that query looks a lot like the specification. The thing that the JSON that it turns the result into looks a lot like the projection part of the specification. This endpoint, you could derive the fact that this endpoint exists from the specification, and that's only executing it. And now inverses. So when something changes, what has to change on the screen? We write a completely separate bunch of code for that. And that code might even be that something happened on a different machine, and so now I have to post a message to a queue, and now I have to have a consumer for that message, and then I have to use server-sent events or WebSockets to, and so you have to write all that stuff, but it's all derived from the specification, just a query inverse and a filter, a feed. So, yeah, I think that's an example. Yeah, exactly. So the information is already there for you to do all of this. Yeah. Anyway. Yeah, we've been talking about that for quite
I'm
a
gonna
bit
have
today.
a look into Cursor myself.
Hmm.
Try to play a little bit with it, because it might help me in development.
Yes. Yes, yeah, because there's a lot of redundancy in WPF.
Mm,
Yeah, with the view model, and then yeah, it's just it's all very redundant. So yeah, Cursor's really good at typing redundant code. I think that's the uh, the theme.
mm. Good, and I'm gonna check where we left off a month ago, uh, and start from there.
Very
Try
good.
to get a model where we left up, because I really
Hmm.
don't remember. I have to go back to the last session we did, and start working again from there.
Yeah. Okay. Well, I'm excited to see what you find.
Mm. Okay, next Thursday you will be there.
Yes. Let me double check. My schedule is just about to get really funky, but uh, just double checking. That is, yes, that is the case. I will be here next Thursday.
Me too.
Excellent.
So see each other next Thursday then.
Yes, indeed.
Michael, thanks a lot. See you then. Bye bye.
All right. Bye.